Here are some simple tricks that you might use to solve integration with trigonometry. So this type of questions where it gives you x equals to something and then it tells you to find the integral of a function. The first thing you should do always is to find the dx. Derivative of sine squared theta is equals to 2 sine theta cosine theta, or by double angle formula sine 2 theta. We start to integrate the function by substituting x equal to sine squared theta into the function, and also substituting dx with 2 sine theta cosine theta. We can separate the square root into squaring the denominator of the function and the numerator of the function. So square root of sine squared theta is just sine theta, and 1 minus sine squared theta is cosine squared theta according to Pythagorean theorem. So we can rewrite that as cosine theta. Cancel out the 2 cosine theta, and we will get 2 sine squared theta d theta. As we don't know how to integral sine squared theta, here comes the second trick, which is double angle formula. The one I use here is cosine 2 theta equals to 1 minus 2 sine squared theta, to rewrite sine squared theta into another form. So here we want to change 2 sine squared theta into 1 minus cosine 2 theta according to double angle formula. So when I substitute sine squared theta with 1 minus cosine 2 theta, I put negative cosine 2 theta in the front and 1 in the back of the function. To continue integrate cosine 2 theta, I set a variable u equals to 2 theta, and so du, the derivative of u, will become 2d theta. And to those who hadn't learned this method yet, it's called u substitutions. By substituting 2 theta with u and d theta with du, I get negative half integral of cosine u du. The integral of 1 d theta will just be theta. Cosine u will become sine u plus theta. And then I substitute u equals 2 theta back into the function to get sine 2 theta plus theta. Since the questions ask to show the whole thing in terms of x, we will now need to change all the theta into in terms of x. So now I want to rearrange x equals to sine squared theta into square root of x equals to sine theta by taking square root of the both side. And now this is what I call a triangle trick. Basically, we draw a triangle and we set theta as an angle of the triangle. Since sine equals to opposite over hypotenuse and it also equals to root x here, root x will become our opposite and 1 will be our hypotenuse. Now we can find the third side by applying Pythagorean theorem. C squared minus a squared equals to b squared. So b will be equals to square root of c squared minus a squared, which will be square root of 1 minus x. And cosine theta will just be adjacent over hypotenuse, which is square root of 1 minus x over 1. And now we can rewrite sine 2 theta into 2 sine theta cosine theta. Since we know sine theta and cosine theta in terms of x now, we can substitute those into the function and get 2 square root of x times square root of 1 minus x, which is 2 square root of x minus x squared. Now we have sine 2 theta to find theta. Since root x equals to sine theta, theta will equals to arc sine root x. So the answer will be negative half 2 square root of x minus x squared plus arc sine square root of x. And to simplify, we cancel out the 2's here to get negative x minus x squared plus arc sine square root of x plus c, a constant. So now let's review some tricks we have used here. So the first one will be always start by finding the dx of the given x. And then second one is utilize double angle formulas and Pythagorean theorem. The third will be using u substitutions whenever available. And then the last one is the triangle tricks. For you to find something in terms of x or find another way to represent your function. Thank you for watching.